All right, so we've got a classic trig sub problem here. We've got the square root of x squared minus 9 all over x to the fourth. Now, because we are dealing with a subtraction here, we know that it's going to be either sine or secant, and because x is first, not a, we know that it's a secant problem. So what we'll do is we'll let x equal a secant theta. And then we'll furthermore say x equals 3, because that's the square root of 9, which represents a squared. 3 secant theta. And then we'll do dx equals 3 secant theta tangent theta d theta, as that's the derivative of x. And now we're okay to go ahead and plug these in. So we've got the integral of the square root of x squared, which is 9 secant squared, 9 secant squared theta minus 9, over x to the fourth. We've got 3 to the fourth power, which is 81. And so we've got 81 secant to the fourth power theta. And then we'll replace dx with 3 secant theta tangent theta d theta. The next step, obviously, is to purge all of the constants. So we'll start by purging this 9 here. We'll extract that 9 and say 9 times secant squared theta minus 1. And then the square root of 9, obviously, is 3. So we'll pull that 3 out, and then we'll pull this 3 out, 3 times 3, over, and then we've got 81 on the bottom. So then we can rewrite this as the square root of secant squared theta minus 1 over secant to the fourth theta, and then we can put secant theta tangent theta d theta on the side there. We can simplify this here to 1 over 9, because that is 9 over 81, times the integral. Secant squared minus 1 is tangent squared, and the square root of that is just tangent. So we're at tangent. And then we actually have another one here that we'll multiply that by, so it's tangent squared theta, secant theta, over secant 4 theta d theta. And then we've got 1 over 9 times the integral, well, not the f, sorry, the integral, where we'll cancel this secant with one of those. And now we've got tangent squared theta over secant cubed theta d theta. And now what we'll do is we'll do some trig math. We'll break this out, and we'll say we've got 2 sine squared theta over cosine squared theta, and then we've got 1 over cosine cubed theta for the secant there. And so what this really represents is sine squared theta over cosine squared theta times cosine cubed theta over 1. So we'll knock out 2 of those, put 1 of those there. And this results in just sine squared theta cosine theta. So we can come back over here now and say 1/9 times the integral of sine squared theta cosine theta d theta. And of course then what we'll do is we let u equal sine theta, and we'll let du equal cosine theta d theta. And so then we've got 1/9 times the integral of u squared du, which of course then is 1/9 of u cubed over 3 plus c, which then of course is 1/9 sine theta, or sine cubed theta rather, over 3 plus c. And we're not done yet. Next we need to build our triangle. So we get our triangle going, right triangle with theta there. And we'll remember that at the top here, the very beginning, we had x equals 3 secant theta. And so then we'll solve for secant theta. We'll say secant theta equals x over 3. Now, cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So that puts our x there and our 3 here. And now we need to solve for what is on that side. And this side I'll just write as y for now. And so we can say x squared equals y squared plus 3 squared. So then y equals x squared minus 9 square root. So this here is x squared minus 9. And so now we can come back here to our solution, and we can say 1/9 times, we have sine cubed over 3. Sine is opposite over hypotenuse. So what we'll have is a parenthesis. We'll say the square root of x squared minus 9 over x cubed over 3 plus c. And then we can say 1 over 9 times, well, we can rewrite the square root of x squared minus 9 as x squared minus 9 to the 1/2, and then raise that, again, times 3. So what that really is x squared minus 9 to the 3/2. So we can rewrite that over here as x squared minus 9 to the 3/2 over x cubed over 3 plus c, which then goes down to 1/9 times x squared minus 9 to the 3/2 over 3x cubed plus c. And then finally, multiply it by 1/9. We end up with x squared, whoops, that was a bad squared, x squared minus 9 to the 3/2 over 27x cubed plus c. And that is our final answer. If you have any other questions, or if you have any other calculus problems that you'd like me to try, leave them in the comments and I will be sure to get around to doing them.